folks. Alrighty. Well, what I want to do before we start getting too deeply into the process of a compiler, so before we get too deeply into scanning and tokenizing and parsing and all that kind of thing, I just want to have a bit of a kind of look back and look ahead at the kinds of things that we have to worry about as we're going through and crafting our compiler, or crafting our debugger, or crafting our formatter, or whatever it might be. So there's a lot of language concerns that come into play. If you've already taken 330, then this is kind of going to be a summary of the second half of that course. And if you haven't taken 330 yet, or if you're just starting to take it now, then this is a look ahead at the second half of that course. All right, so one of the things that we have to think about is the fact that we've got a source language and a target language. And it might be the case that we're simply coming up with some kind of formatter or optimizer where it's the same language. We're rewriting a program from one language to the same language, just in some kind of different fashion. But usually we're either translating from one language to another, or we're taking source code and we're producing byte code, or we're taking source code and we're producing object code, and we're going to assembly language or to machine language or something along those lines. So we have to be aware of the nature of the language that we're coming from and the nature of the language that we're going to. So part of that are concerns with the paradigms. If your source code is an OO language or a functional language or a logic programming language, and we're translating to something that's procedural, we're translating to C, or we're translating to assembly language, or to machine code, then we're going from one paradigm to a very different paradigm. So we have to think about the implementation issues there. If, on the other hand, we're doing something like a translator, where we're actually going through and saying, okay, well, I'm going to translate from, from Prolog into Lisp, right? If we've got two very different paradigms in play, then we have to be very aware of both of them and how we can go from sort of this original implementation in one language to an implementation that's necessarily very different in another language. So that's one of the things that we're going to have to address. Along with that, there are going to be sort of priorities and purposes with different languages, right? Some languages have very specific purposes. They're very focused on, web pages, or very focused on text manipulation, or they're general purpose languages, right? So they're but focused on efficiency, or some of them are focused on, ease of use. All sorts of different priorities that we probably need to be aware of as we're developing our translations. Obviously, in terms of the features of the language, there's a lot to worry about in terms of the data types that are supported in the language that we're coming from, and the operators, the operations that are supported in the language we're coming from, and what's actually supported in the target language. Again, if we're going from a language with a very rich suite of data types to a very limited assembly language, then this is going to have a big impact on the compilation process, on the translation process. If we're going from a language with a very rich set of data types to another language with a different, very rich set of data types, then how are we going to handle that? What's the best way? What's the best form of translation to use? Dealing with things like exception handling, dealing with nested scopes or dynamic scopes, dealing with the different forms of ifs and cons and whatever else might be supported, dealing with the different kinds of iteration, the different forms of loops. Does the language we're coming from have a for each? Does it have a for? Does it have a while? What would that look like in the target language? What do subroutines look like in the source language and in the target language? Can we have nested subroutine declarations? How is that going to be handled? Are we using static typing or dynamic typing? How is that going to be handled? What kind of runtime type checking takes place versus what sort of compile time type checking takes place? These are all issues that we're going to have to address. So I want to run through a bunch of these just quickly. We won't spend a huge amount of time on this in this session, but just again to kind of recap what's out there. And obviously when we go through the scanning, the tokenizing side of things, we're going to be looking at the alphabet that our source language actually supports and whatever's going on in our target language. We want to look at how we're expressing the tokens in our source code language, dealing with any overlapping tokens, right? If we've got, again, keywords that sort of have the valid form for an identifier, how's that resolved? Are there practical limitations on the tokens that we're working with? Maybe the definition of the language says variable names can be any length at all. Well, if I'm actually writing code for this, I've got to come up with some kind of a practical limit, right? I can't just go through and arbitrarily create a character array that's going to hold whatever size of identifier they throw in. So you're often going to find yourself, when you're writing your compiler, you're going to find yourself applying or imposing limitations that aren't specified by the language itself. Is there a maximum length string literal you can use in the language? Is there a maximum length identifier you can use? All of these sorts of things are going to come into play. And again, related to the use of the tokens, are there context-sensitive keywords? Are there words that are reserved across the use of the language, across the source code language or across the target language? Are there user-defined keywords and whatnot? So all sorts of issues to deal with there. Again, as I mentioned, we have to think about the primitive data types that are supported. What kind of support does the source and the target language give you for different sizes of integer, or different sizes of real, or different precisions of real? Does it support fixed point or scientific notation? Do you have support for booleans? What do characters look like? What does the character set look like? Does it support ordinals? Do we have enumerated types or ranges or subranges? Again, are there limits on the different data types? So is there a maximum integer? Probably. Is there a maximum length string? Probably. What's the maximum precision for a real? What's the maximum absolute value, if you like, for a real number? Right? What are the defaults? If somebody just declares a variable of some particular type, does it get initialized with the default value? And all sorts of things that we'll want to think about when we're actually turning their source code into, for instance, into object code. Again, we have to be aware of the operations, the precedence rules, the associativity rules. They might be different in one language versus the other. And then all sorts of practical concerns in terms of how do we allocate storage for the types, how do we access that storage, how do we handle things like underflow and overflow. We'll get into type checking a bit very shortly here. And then you start looking at the compound types or the complex types. If we've got arrays or vectors or strings or sets or lists or structures or unions or hash tables, what data types are supported in the source language, and what do we have available in the target language? Again, what are the built-in operations or functions on these things? If we're dealing with compound types and we do something like an assignment statement, are we looking at shallow copies or deep copies? What kind of an impact does that have? How do we handle these things with parameter passing? Again, where does storage allocation and initialization and default values come into play? If I have to handle things like resizing arrays or moving arrays, if I'm passing these things as parameters or as return values, what are the implications? How do I have to deal with this? Right? These are all issues that we have to know about and deal with when we're crafting our compiler. All of the type checking issues. Does our language, our source code language and our target language, are they using static typing or dynamic typing? Right? Do we do our type checking at compile time or at runtime? If something goes wrong at runtime, do we just let it crash, or do we actually insert some kind of runtime checking? So what kind of support or enforcement do we have for type checking there? Are there implicit type conversions? Do we support explicit type conversions? What are the rules around that? Are there user-defined types? What kind of type checking takes place with those? If we've got data structures, if we've got a list or an array and we're trying to compare the two arrays, do we do sort of structural testing on those? Do we do, if you like, deep comparisons on those? Do we have named data types and if we're going to compare two things, the type of two things, do we just compare the names of the types for the two of them, or do we actually compare the structure for them? How do we deal with conversions that are narrowing or widening? All issues that we have to be aware of and we'll have to deal with. When we're playing with variables or when we're playing with constants, what are the data type rules? What are the scoping rules? How do we resolve the use of a variable name in deeply nested scopes or with dynamic scopes? What are the lifetimes of variables and constants? When do they get created? When do they get destroyed? When do they get initialized? Can they be changed? What kind of memory allocation do we use for these things, right? Where do we put these things in storage? Can we move them later? Right? What kind of initialization rules do we have? What kind of default values do we have? Right? All of these things we're going to have to deal with no matter what. Even if there are things where the language doesn't specify something, we're going to have to come up with a rule for it. We're going to have to come up with an implementation, and we're going to have to deal with it. Right? Block rules, scoping rules. Do we have blocks with, we have to think about the entry and exit points for blocks in the source language and in the target language, right? If you've got a loop, do we have multiple entry points to the loop? Do we have multiple exit points to the loop, right? Do you have break statements where you can jump out of the loop at any point? Is there a way to jump into a loop? So things like the C switch statement where you can use it to cross all sorts of boundaries that you really shouldn't. Again, what kind of scoping rules do we have for blocks? If I declare a variable outside a block and I declare a variable with the same name inside the block, is that allowed? Are they different variables? Are they different scopes? How is that scope enforcement implemented? How do we deal with storage allocation across the different blocks, across the different scopes? Thinking about selection, this is pretty obviously going to be one of our concerns, things like if statements and if else's, and are there case statements? Do we have things like the Lisp type cases as well? What are the different kinds of constructs we have to deal with in the source language, and do we have available to us in the target language? And what's the right way to handle them? Do we look at, if you like, what's the optimal way to write our selection statements to optimize size and speed, efficiency? Right? If somebody gives me a case statement, how am I going to turn that into assembly language that's efficient? If somebody gives me a case statement in one language and we need to translate it into another one in another language, how is that translation going to work out in an effective way? Right? Things like branching and labels, right? If we're thinking about the implementation, the under-the-hood implementation of things like if statements or loops, what are the tools that we've got available to us to implement those? And again, what are the effective test and branch mechanisms? Are there unconditional branches, things like a goto essentially? How does this relate to the scoping rules for the two languages, the source and the target language? Do we have jumps across scope? And if so, what happens? Can we have jumps that go across subroutine boundaries? And if so, what does that mean? Again, iteration, going back into the loops, and we've probably got for loops or while loops or do while loops or repeat loops or whatever it might be. Do we have iteration across collections of values? So things like a for each, and if so, what kinds of data values does that support? What kind of collections does that support? And if it's not supported in the target language, what do we do? Again, multiple entry points and exit points, breaks, continues, final statements. How does all of this interact with the scoping rules? And all sorts of considerations. If we're looking at subroutines, do we just have, if you like, global subroutines where you declare a function and you can call it from anywhere else in the file after that? Do we allow nested subroutine declarations? Can I declare a function inside the declaration of another function? And if so, where is that visible? What are the scoping rules around that? What are what's the definition form, and what does the call look like? What kind of parameter passing mechanisms are supported, again, in the source language and in the target language? Can we have support for optional parameters, for variadic parameters where you can have any number of parameters passed to a function? Do we use positional passing or keyword passing mechanisms? Do we pass by value, pass by reference, pass by name, pass by value return? There's all sorts of different parameter passing mechanisms that could come into play. And again, source language versus target language. What do we have available? What do we have to support? What's the relationship to subroutines in scoping? Are we using dynamic scoping? Are we using just straightforward static lexical scoping? What are the scoping rules we're playing with? And what kind of an impact does that have on our development of a compiler or a translator or a debugger or a formatter? All right. Dynamic memory handling. Is this something that's explicitly provided for the programmer? Is this a C style where they've got pointers and they can ask to allocate new chunks of storage? Or is this something that we're handling behind the scenes? Or is it both? Do we do some automatic handling of things and the programmer is also allowed to have their own control over some of it? What kind of garbage collection do we use? Do we have support for sort of smart pointers or dumb pointers, if you like, in a C style or C++ style of language? Again, in terms of abstract data types or object-oriented language, what kind of support and what kind of enforcement do we have in the source language and the target language? How do we actually go about implementing fields and methods? What kind of support is there for abstraction? What kind of enforcement is there for abstraction? What kind of access controls are there? Do we have public, private, protected? And if so, what does that look like in the target language? If the target language is assembly language, how do we make that work? Do we have inheritance? Do we have single inheritance, multiple inheritance? Can we override fields or methods when we inherit? Do we do static or dynamic binding when we're going through and resolving methods? What kind of type checking do we have on the objects? What kind of type conversion is supported between objects or between data types? When do we allocate and deallocate these things? And this comes back to the garbage collection ideas. And is it automatic, or is it something that the user controls? Do we support sort of generic classes or abstract classes? Do we provide support for templates? Do we provide support for exception handling? Is that something we have to deal with? And if so, again, what does that look like at, say, the assembly language level when we're trying to build this? Or what does it look like when we're translating this into another language that doesn't actually support it? Do we have a hierarchy of exception types? And if so, how do we go through and implement that? What kind of control structures are we supporting? Right? What kind of a relationship does our exception handling have to the scoping rules for the language? Again, in the source versus the target language. Right? There's a lot of issues we're going to have to deal with. And of course, there's probably a ton, well, there is a ton that I've left out, but some of it's going to be specific to whatever makes that particular language unique, whether it's your source or your target language. Or there's going to be issues related to the specific platform that you're targeting for this, right? That introduce new issues that we have to consider. Right? We've mentioned earlier that we're going to think about optimization issues as well. Optimization at kind of a generic code independent level, and then optimizations at the platform level, at the target level, if you like. So there are a lot of issues we're going to have to deal with when we're going through and developing our compiler or developing our interpreter or developing our debugger. And so this is all stuff that we want to take a look at as the term winds along. All right, that's a good place to leave it for now.